In the figure shown, the plates of the parallel plate capacitor have unequal charges. Its capacitance is C. P is a point outside the capacitor and close to the plate of charge minus Q. The distance between the plates is D. Assume D is smaller. Say this is the left plate of the capacitor and this is the right plate of the capacitor, as we see, and 2q is the charge on left one and minus q on the right one, and point P is close to the plate possessing charge minus q, and P is outside this plate, right? So now we are having four options. The first option is saying a point charge at P will experience a force due to the capacitor. Okay, so here is the capacitor, and right we may say some charges, say some q charges here, and this charge feels some force. This is what option A says. So for that, what we have to find is electric field at P should be found due to individual plates. Okay, so let me say this is a plate A and this is a plate B. At the point P, the electric field will be in this direction, and that electric field will be is equals how much? This is only due to the plate A. Okay, so the amount of charge is 2q divided by 2 epsilon O into A, if A is the plate area of this one. Okay, so meantime, this one, which is the negative plate, that is B. Okay, so at point P, the electric field due to the second plate, that is B, will be to the left side. Okay, so will be to the left side, and this electric field is EB is equals what I can write. It is Q divided by, okay, 2 epsilon O into A, and these two electric fields are acting in opposite direction. Okay, so therefore net electric field at P, okay, net electric field at P is simply E is equals which is EA, which is acting to the right side. Okay, so and the left side electric field is EB, that should be subtracted, that is EB, and that is E is equals how much? It will be 2q divided by 2 epsilon O into A minus q divided by 2 epsilon O into A. So certainly E is equals, it is simply q divided by 2 epsilon O into A. This is the electric field, right? So now the force and remember this electric field is acting in the direction of EA, which is greater, right? So that we can show with a different color, say this. So this is the direction of a net electric field. Okay, so in the same direction we can feel the force. How actually we write the force? So force is equals the charge which is under interest, that is q, right? So this is the charge what we are placing at point P into the electric field. So that means AF is equals q into E is q divided by 2 epsilon O into EA. So this will be the amount of force that a charge q, small letter q charge at P will feel. Okay, and this electric force is acting in the direction of net electric field, that is to my right side in this direction. Okay, now the option A is what we observed is correct, right? So let us think about option B. The potential difference between the plates will be 3q divided by 2c, and for that I have to assume a point here, say point M. So at point M, there will be two kinds of electric fields. One is due to this one. Okay, so that is plate A. So that is acting to this side. This is EA, and from this one negative charge, this is also acting to the right side. It is EB. And now at point M, which is in the middle region, of two plates at point M, what happens? The net electric field will be what? It is EA plus EB. I have to add them. Okay, so what should be the electric field at that point? That is the sum of these two. So let it be explained here. See this. EM is equals, what I can write? EM is equal to EA. It is 2Q divided by 2 epsilon O into A. And how much is EB? Which is Q divided by 2 epsilon O into A. And both electric fields are acting in same direction. For that, I am simply adding them together. EM will be is equals, it is 3Q, right? 3Q divided by 2 epsilon O into A. This will be the net electric field at the point M. Where is M? M is in between the two plates. Here is M, right? At this point M, we are having this much electric field. This much electric field. Now, by definition, what we can write is, potential difference between the plates will be what we can do. So that is V is equals E into D. This is the thing what we can put. So that is V is equals, it is 3Q divided by 2 epsilon O into A into D, right? This is the electric field what we can think about the present situation. And here in option B, we are seeing a term like C, that is capacitance. How we can write the capacitance now? We have to include it. By definition, what I can say, C is equals, it's geometrical structure, right? EO divided by D. And here is EO into A and D. That is the reciprocal of this, right? So 1 divided by C is D divided by epsilon O into A. That means in this place, yeah, for this, I can put 1 by C, right? So that is what I am going to do now. That means V is equals, it is 3Q divided by 2C. So this is the potential difference between the two plates. Now see option B. The potential difference between the plates will be 3Q divided by 2C. This is right, right? So option B is also right. Already we saw that option A is right, and now B is also right. So let us think about C. The energy stored in the electric field in the region between the plates of the capacitor is, right, this much, 9Q square divided by 8C. How actually we write the term energy? So the energy can be written in a different sense. This is energy U is equals, just like capacitor means half CV square we can write. Okay. So now what we got for V, it is 3Q divided by 2C. So that is half C into 3Q divided by 2C. It should be squared. So that will be is equals to 1 divided by 2 C into 9Q square divided by 4C square. One term of C that cancelled. Therefore, U will be is equals how much? It is 9Q square divided by 8C. 9Q square divided by 8C. Let us see what is given. 9Q square divided by 8C is our answer. 9Q square divided by 8C is also here. That means option C is also right. The force on one plate due to the other plate is. Okay. So the force on one plate due to the other plate is. So now think about the situation like this. We are having this kind of one plate here, and one more plate we are having, which is here. What I said, this is plate A and plate B. The charge on A is 2Q and B is minus Q. Okay, so let us think that the electric field at any point N. Okay, N is a point on the plate B. and what I said, this distance is very very small. Okay, so this distance is very small. At that moment, electric field at n due to the plate A will be it is 2q divided by 2 epsilon O into A. This much will be the electric field at this point. Okay, at n at n. So this is the electric field only due to the plate A. So now, therefore, the force on plate B due to this electric field will be how much? It is F is equals electric field at n into the charge on the plate, which is minus q. So that is nothing but what En is, which is 2q divided by 2 epsilon O into A, and the charge is minus q, right? This much. If I put minus q, nothing happens. Now see, this is a minus 2q square divided by 2 epsilon O into A. Otherwise, simply I can write F is equals, it is a q square divided by epsilon O into A with a negative sign. Okay, so with a negative sign. So this much will be the force, which is q square divided by, right, which is q square divided by epsilon O into A. But what it is said here, it is q square divided by 2 epsilon O d square. It never depends on this one. So that means this option is wrong, right? So this option is wrong. And one thing I have to tell you, what the negative sign we got here, that means the force on this one, this plate B, will be in this direction. This is the direction of the force. Okay.